Okay, we're going to start. Here we go. Okay. Quiet, please. No more talking. Here we go. We're looking at number 4. So how do we find the 1 unit growth factor? So that's about understanding what that is, what it means. What is the 1 unit growth factor? Can anyone articulate it in a good statement? I know Jad can. Eric?
Well, it's not the growth factor.
Not to find it. What is it?
Oh, what is it?
What is the 1? That's the key.
It is what the output of the previous input grows by each time.
What it grows by. I want to be a little more specific. Elon. Eitan. What you multiply the last output by to get the new output. Right. So grows by is a little vague. So we want the actual growth factor is a multiplier. That's the key. It's a multiplier on output to get the next output. So if we've got 260 and our next output's 299, what are we going to do to get that multiplier? Yeah, it's going to be 299 over 260. And then to get the 1 unit percent change, we actually want to find that value. Anyone got a calculator handy? Or remember what that was? 1.15 exactly? Where am I? Yes, I wanted to be here. Exactly, you're right. Exactly 1.15. These are the types of growth factors we like the best because you can just pick off the 1 unit percent change easily. What's the 1 unit percent change? 15% growth. Okay? What's the percent change if the growth factor is 6.8? What's the percent change if the growth factor is 6.8? That's harder. You gotta know what you're doing. 680%. 580%. You have the 1 from the stuff from before, right? So in this, you have the 1 from before plus the additional 1.15. So this is the same as 1 plus 5.8. 580% increase per unit. Okay? Initial value, 260, right? Oh, you're so smart. All right, so yeah, we need, so if I make a new column in here, 0. So we're asking, what is that initial value? Okay, yeah, a couple ways to do this. One way is, okay, if 260 times 1.15 advances me to the next output, dividing by 1.15 will take me back 1, and that's what I want. I want to go back 1. So you can do 260 divided by 1.15. $226.09. Function g of x then is initial value times, and when you see 1.15 to the x, you see that, but you think what? When you see 1.15 to the x, you see that, but you think, Michael.
So x times 1.15 times itself x times.
1.15 times itself x times. A string of 1.15s multiplied together. X of them. So if we're talking about what? X equals 10. Then we have the initial value, and then to get to the 10th unit, we would multiply by 1.15 10 times, right? That's why we do it to the 10. That advances us forward 10 units. So keep thinking about the meaning when you look at the function. So it's very easy to fall into the temptation of, once you've got the function, you just get in, mind off mode, and you're just plugging and chugging, right? Keep thinking about what that that exponential part means, because that's where the growth is seen, right? So that's like what's characterizing the growth is what's happening right there. So you should understand that. And there'll be test questions that won't just be plugging into the function. They'll see if you understand stuff like that, okay? Question not 4. Jad, did that clear it up? Or was it Danny?
Yeah, 4.
That cleared up?
Yeah.
7. Okay, so here the thing that's kind of the curveball here is they're giving you values of output for negative values of input, but that doesn't phase us, right? There's nothing different about this. Where am I? There I am. All right, so if at negative 2 is 25 and negative 1 is 30, how do we find the 1 unit growth factor? 30 over 25. So negative 1 is the next output from negative 2 because it's an increase of x of 1. So if you're at negative 2, you increase by 1, you multiply by the growth factor. So it would, this is the direction of multiplying by the growth factor. So the growth factor would be 30 over 25, which is 1.2. 1 unit percent change, 20%, initial value, piece of cake, right? Here we are at negative 130. What can we do to get the, we're 1 unit away from the initial value, right? We're at negative 1, so we want to find what the output is at 0. So we just, all we have to do is take 30 and do it. Times 1.2. Use the growth factor. Use the idea of the growth factor to get then that output. The next output after negative 1 will be the output at 0. 36? Yes, 36. Function then is, did they name it? Make it up. H of t. H of t is 36, 1.2 to the t. Any more questions on the homework? Is that good? Okay, let's keep going with this. So we'll just keep building on what we're learning with these multi-unit growth factors. This is not bigger. Okay, here's the situation. Initial mass of 50 micrograms of bacteria in a Petri dish doubles every 7 minutes. Okay, so we want to complete the following table. Round mass values to the nearest 100th microgram. So it doubles every 7 minutes. That's the key to getting started here. What does it mean? If the mass doubles every 7 minutes, how can we use that information to talk about exponential growth? I heard multiplied by 2. So then what kind of number is 2? The growth factor. Now we know for a given situation there's many growth factors, right? Which growth factor is 2? The doubling growth factor. The 7 unit or the 7 minute growth factor. So that's where we can start. And right away we can look at this table and say what? 7 minutes is 100. If it's on. Okay, so we see that to get from any output to the output 7 minutes later would be a growth factor of 2, meaning we multiply by 2. So then at 14, what's the mass at 14? That's another double. That's another 7 minutes gone by. So it doubles. Okay, so we want to find then what we're really interested in, say, is the 1 minute growth factor. The 1 minute growth factor. So we don't know what that is. So what can we do? This process I'm about to do is really important. You need to know how to create it, recreate it. Don't just wait for what you think is the punchline. This is the punchline right now, what I'm about to do. So we don't know what that 1 minute growth factor is, so we can call it what? So we're used to our general form is f of x equals a b to the x. So what would be a nice choice for a symbol for our 1 minute growth factor? A? B. Okay, so B is what we're used to as the 1 unit growth factor. So we'll use B here. So how would I get, if I call the 1 unit growth factor B, how would I get the mass after 1 minute? What would it be? If the 1 unit growth factor is B. Divide by 7. Divide 2 by 7. Okay, you guys are missing the point. 7 through to 2. So you're just going right to the answer. If the 1 minute growth factor is B, listen to my question. If the 1 minute growth factor is B, then what is the mass after 1 minute?
50B.
Go ahead, Adam. I heard you. 50 times B, Mitchell. Yeah, that's what he said. 50 times. That's right. 50 times B. Why? You should think that and understand that. Am I in the right place? Oh, there's just nothing there. I'm stuck. What's going on? Here, try this. There we go. Do you understand that? You should. B is the 1 minute growth factor. We know that's the multiplier on output to get the next output. So if we had 50 1 minute, then the next minute we're going to have 50B. So we're multiplying by what? Times B. Okay, what about after 2 minutes? 50B squared, or 50 times B times B. Every minute you multiply by B. This is the whole point that we started talking about with so then we ask, so this is another times B, right? So every minute, it's the same thing. So now we have 2 ways to get from this value of the mass of 50 to the mass of 100. There's 2 different ways. One way is, the first way that we saw to get from the mass at 0, 50 to at 7, 100 was the first way. Multiply by 2. It doubles every 7 minutes. But now we have another way to construct how to get from this mass of 50 to this mass of 100. What else could we say is a way to get that mass of 100 from the mass of 50? I know Danny knows. How about this Nick right here? Do you know how to, the second way? So we can multiply by 2 to get from 50 to 100, but then we could also do what?
You can also locate the growth factor.
Okay, it's B. So we said the 1 unit is B.
Also, you can set it in exponential form, 50 times B.
So I want to use that B to go all the way from 50 to 100. How would I do that using the B? You had the right idea, but I don't care about the middle now. So how would I use that B to go all the way from 50 to 100? Every time a minute goes by, you multiply by B. So if 7 minutes go by, what do? Multiply by 7B? B to the 7th. So 2 is the same thing as, where's my red? Do is the same thing as B. Do you see it? Every minute we multiply by b, so after 7 minutes we will have multiplied by b 7 times. But we know that that's doubling. That's 2. So 2 equals b to the 7th. So then what is b? So now we've got something we can solve for b. And this was, so we need to take the 7th root of both sides. 2 to the, so we just found the 1 minute growth factor. What about taking 100 minus 50 and dividing by 7 and going that equal amount each time? Does that work? So if I took 100, I'll do it here. $14.28 is oh sorry, I meant 50 divided by. I did the wrong thing. So I did 50 divided by 7, and I got 7.1428. Is that how much the mass goes up every minute? Does the mass go up 7.14 micrograms every minute until it reaches 100? Is that exponential growth? What kind of growth would that be? Constant rate of change. Every time a minute goes by, you add the same amount of mass. That's not what's happening because we know this is based on multiplication of the growth factor. Okay? So you can't just take the change of 50 divided by 7 and say it goes up by 7.14 micrograms because that's constant rate of change. That's not exponential growth. Okay, so how do we find the 1 minute percent change? We need to get this 2 to the 1/7. So I'll do it here. Equals 2 to the 1/7. $1.104. 1 minute percent change then. $10.4%, right? So we know the 1 minute growth factor is 2 to the 1/7. I found its value, 1.104. Let's get rid of this 7.14. We know it doesn't matter to us. So based on that, the 2 to the 1/7, 1.104 is the 10.4% 1 minute percent change. Okay, any questions on this process that I've done in blue and red here? You got to understand that. Don't just try to memorize tricks and rules. I mean, that will get you somewhere, but if you come to something that's different, then you won't know what to do if you just memorize stuff. So this kind of reasoning can solve, you'll be able to solve lots of problems. Okay, so you got some more tasks here while I take attendance. So for this situation, find the 4 minute growth factor and percent change. What's the mass at 18 minutes? Using the growth factor, do it the simplest way. Don't use the function, use the growth factor. And then write a function for the mass with respect to n, the number of 10 minute periods. So you've got 3 more tasks here to work on. Jerome can walk around. You can work together. Okay, we're going to regroup here. Let's go over these. Attention in the front, please. Did you get it? No, the 4 minute growth factor. Tell me how you got it. 4 times the 1 minute, 4 times 2 to the 1/7. Is it? Tell me your name again. Yeah. Riley. He wants to do 4 times 2 to the 1/7 for the 4 minute growth factor. You agree with that?
No.
What do you want to do?
For the 4 minute growth factor, I did 2 to the 4/7 over. Not. Alright. What did I do? I got 1.486, and to do that, I got what the mass was at 4 minutes and divided that by 50.
Okay, you could do that. So you found the mass at 4 and just divided by 50. How could we do it just having the 1 minute growth factor? Christopher?
I did
50 times b to the fourth, and then I plug the b in, which is 1.104.
Okay? Yep, that's good. So you solve for b? Or you solve for, yeah. Danny?
Since you know the 1 minute growth factor, which is like 1.104, just put that to the fourth power. And you have
Yeah, so now what we're really talking about is here. 1, 2, 3, 4. We need this growth factor now. And if every minute you multiply by b, then what do you multiply every 4 minutes? It's going to be that value of b to the fourth, right? You're going to multiply it by that b 4 times, which is 2 to the 1/7, 2 to the fourth, 2 to the fourth. So there are many ways. Lots of you had valid ways. This is the easiest. Take the 1 minute growth factor, multiply it together 4 times. That'll advance you 4 units of input. And so and this is also 2 to the 4/7. What is that value? Equals 2 to the this is in some weird format here. This number. Did you get 1.49? That's what I got. Percent change? 49%. Okay, so now what's the simplest way to find the mass at 18 minutes? Who's on this? Matt?
Take your 50 and multiply it by your growth factor to the 18th.
That works. So you're going to take 50 and multiply by 2 to the 1/7 to the 15th.
18th.
What did it say?
18th.
To the 18th. 2 to the 1/7 to the 18th. Is there an easier way? Matt? No. Yeah. No, Chad. Sorry, Chad. Okay? Right, it's a little bit easier. You see that? So what you did was perfectly good. But you could, if you want 18, you could start with 14 and multiply by the 4 minute growth factor. That'll advance you to the input of 18 or the output for an input of 18. That's the easiest way to do it. So you're going to take 200 times the 4 minute growth factor. But starting with 50 and multiplying by 2 to the 1/7 18 times also works. There's an extra little part to that. So just make sure we have the right number. So what is that? What do you got? 296 point, or it says hundredth. So 76, 77? Yeah, 77. Okay. So that is the result of taking 200 and multiplying by 2 to the 4/7 times your. So that's the kind of thing you should be able to do, able to see and do. Oh, I wanted it 18, so I look at 14 and I've got the 4 unit growth factor handy. Multiply the output at 14 times the 4 minute growth factor. That will give me the output at 18. That should start coming quickly, that kind of thing. All right, so now we want to write a function. I didn't give you a name? Okay, so the number, let's just do f. So f of n. What will f of n be? Natalie, did you get f of n? 50. N over 7? Does it work? So if n is a number of 10-minute periods, okay, so let's rearrange things here. Yeah, now you got it. So let's do 2 to the 1/7. And we want the 10-minute growth factor. So how would we get the 10-minute growth factor out of that? Yeah, to the 10th. So now that whole thing is the 10-minute growth factor in the brackets. And in the function, we want that raised to the? Yeah. So then you can write 2 to the 10/7 to the n if you want. So with a 1 minute growth factor, I can get the 10-minute growth factor by multiplying the 1 minute growth factor together 10 times. And then and I want that because if n is going to take me 10 minutes at a time, so that's going to be my exponent, then I need the 10-minute growth factor. Eric?
So I totally agree with what's written up there, but it could probably be written a simpler way.
Okay.
I just have 50 times 1.104 to the 10 to the power of n.
Okay, so yep, so you actually used what? You used this value of, did I ever write it down? This one.
Yeah.
So you put, this was your 2 to the 1/7, and then you took that to the 10th, and then to the n, right?
Yeah, and Michael even has an easier way, actually.
Oh, okay, I'm all about that. Tell me.
So if you multiply out 1.104 10 times itself, you get 50 times 2.69 to the n power.
So you're just finding what this 10,
Exactly.
yeah. So this is the 10-unit growth factor. So what is the advantage to what I've written over what they're saying? Okay, so you can see where it comes from. You can see what it is. Yeah. And then it's exact, right? So there's 2 advantages to what I have. That you can see exactly what it is. We took the 1 minute growth factor, and we found the 10-minute growth factor from it. And then we have exact results. So, but it's totally legit as long as you save enough. So what is 2 to the 10/7? You said it was 2.69? Okay, so as an approximating function, that's valid. Now, there's an advantage to that form. Looking at this as the growth factor, what's the advantage to that form? Seeing that 10-unit growth factor as 2.69. There's something else you can deduce from that.
There's less room for error.
What's that?
Less room for error.
No, there's error in this. You rounded.
Yeah.
You just made error into it.
Yes, no, yeah, like since you rounded, there will be some error, but once you get to that point, it'll kind of be easier to put in the number of 10-minute periods that you want right there. It just looks easier to me.
Okay. But it tells us something also.
The percent change.
What is the percent change, Nick?
In this case, it would be 200.
How much? What percent? 169% increase. You can't see that here, right? You can't see that here, but here you can see 169% increase. About, right? So that's a decimal approximation. So it's about 169% increase. Okay, cool. So let's practice more. Any questions on this? Yeah, please.
200 times 2 to the 4 7.
Yeah. You got it. Okay, cool. What'd you get?
297, but it's still close, right?
I'll put it in exactly here.
297.
I'll do equals 200 times 2 to the 4/7. This will be exact here, or a good approximation. So here's a better approximation. 200 times 2 to the 4/7, 297.2. So yeah, you're right. That's different. So 297.2 is a better approximation for that. Other questions on this? Okay, so growth factors everywhere, right? So given a situation, we're finding there's many, many growth factors in a given situation. And we need to know how to move back and forth between them. So this is number 6. The setup is number 6 somewhere on some page. Investigation. 4 maybe? Who can find it first? Is it 4? Please. You're wasting time. Maybe, okay. Anyone find it? 140? Page 140. Here's the setup in blue. The body removes 85% of whatever ibuprofen is present in the bloodstream every 5 hours. So every 5 hours, the body removes 85%. Okay? So you're going to take 500 milligrams at t equals 0 hours. So here are your tasks here, okay? So they're labeled right down 1 through, in a second I'll number the rest. But so let n be the number of 5-hour periods. Define f of n. Okay? Derive the 1-hour decay factor. I want you to derive it, like we did in the last example. Actually derive it. So call that 1-hour decay factor, call it b, and reason your way through the value of b. Okay? Even if you know what it is ahead of time. Show that process. And then I've got the rest of the questions there. So go for it. Work together. We'll come around and help you out. Is there something I have to change up there?
Oh no, I was just trying to.
Get your bearings straight?
Yeah, I was just making sure I had what all the numbers were.
Okay.
So, we're good.
Hey, make sure you get number 1 right. If you want us to check number 1, let us know. That's number 2. Do number 1 first. Yes. Yes, right. So then. Oops, 85%. Check number 1. You gotta get number 1 right. And it's the number of 5 hours.
I guess doses,
That is the number of 5-hour periods. That is the number of 5 hours. It's only 1 hour period. Yeah, that would be true. N is a span of 5 hours. So every 5 hours, that's right. The decay factor is That'll just give you a single value, and that's what that is. This is another 5-hour period. Every time 5 hours goes by,
So he's 60 years of class.
sure, 1.5. Every time 5 hours goes by, you multiply by 1.5.
Okay.
You got it. You got it eventually. Guys, good questions? So if B is the 1 hour growth factor, what does 0.15 equal? If B is the 1 hour growth factor or decay factor, then what does 0.15 equal in terms of B? 0.15 is what you multiply by every to get it 5 hours later. If B is what you multiply to get at 1 hour later, then what is 0.15 in terms of B? B over 5. Lexi, do you agree with that? B over 5. 5B. B to the 1/5. Look at what's happening, you guys. To get the amount of ibuprofen the next hour, you're going to multiply by B. So to get from 0 to 5, what would you do with B? To get the, you multiply by B 5 times. B times B times B times B will advance you 5 hours in output. Well, we know that's 0.15. So 0.5 equals? Ooh, that's painful, you guys. B to the 5th. B times B times B times B times B advances you 5 hours in terms of amount of ibuprofen. We know that's 0.15. Therefore, B equals 0.15 to the 1/5. Solving for B there. Solving for B. B is 0.15 to the 1/5. And what does that equal? Percent change per hour. 68.4% change per hour. No, negative 31.6. Negative 31.6, right? 0.684 is how much you keep every hour. Decay factors is the portion that remains. So you do negative, you're going to negative 31.6. All right, so let's just do the growth factors. What's the 1 hour growth factor? Oh, 1 hour percent change. All right, so we got that. Number of minutes. What's the 1 minute growth factor? Okay, here we go. It's 0.15 for number of minutes to get the growth factor. .15 to the 1/5 to the what? 1/60th. It's the number we'd have to multiply together 60 times to get our 1 hour growth factor. So it's 0.15 to the 1/5 to the 1/60th. Half days, growth factor. That's the 1 hour. Half day is no, 12. Not 1 over 12, 12. Because we got the 1 hour, we're going to multiply that together 12 times to get 12 hours. If you want to come get some of these results from or the answers from me, I'll stay around and you can find out if you did it right, okay?